Hey guys, let's talk about vector addition this session. There are two laws which actually govern this addition. This is the triangle law and the parallelogram law. Now, the question is, why do we need new rules to add vectors? Why can't we just say like 6 plus 4 is 10? Well, that's a simple addition we know. In vectors, 6 plus 4, if at all I have a direction, may not always be equal to 10. It can be 5 also, it can be 3, right? Let's see why is that in the case, all right? Now look at this. Let's suppose we have a boy here who just wants to walk in this direction. So let's suppose it walks in this direction. Let's say the modulus of this vector A is nothing but 6. What do you mean by modulus? I'm just talking about how much did he walk. Let's say 6 kilometers he walked, right? In the direction of this arrow. Beautiful. Then the boy decided to walk like that. So then I say the modulus of vector B here is 4. So overall, we know very, very clearly that the boy actually walked 6 plus 4 kilometers, which is nothing but 10 kilometers. Now, if I ask you to add these two vectors, right? When I say add two vectors, the answer should be a vector. It means it should have only one direction. So how can I represent the addition of these two vectors in a single direction? I don't know. The boy is here. The boy is here now. The only thing I know is the boy is moved from here to here. Correct. So if I say the boy has moved 1, 2, 3, 4, 5, 6, 7, and 8. So the boy is actually displaced himself from this point to this point. And the distance traveled is like 1, 2, 3, 4, 5, 6, 7, 8. In this case, let's say that is vector A plus vector B. That's how we add. And the modulus of this is given as 8. Now that is interesting, right? So I know that is 6 plus 4 is 8 in this case. That makes sense? Exactly. That's what happens in vectors. That the sum of 6 plus 4 is not always 10. So we don't write 6 plus 4 is 8. That becomes wrong. We can write that modulus of vector A plus the modulus of vector B is equal to the modulus of vector A plus B. Well, that makes sense to me. Okay? And in this case, I can write that is 6 plus 4 is 8. That makes complete sense to me. Now, why did we have different rules for this? Because when I have to express the sum of two vectors, I just need one direction. I cannot have two directions. So why do we need new rules? Just because two vectors, when they added, I need to get another vector. It means I just need one direction. But there are two directions here. So this represents one direction and also the displacement. That gives me the vector addition of these two guys. Completely makes sense, right? Beautiful, guys. Let's come back to the second situation. That's a triangle of addition. Just because these two represent the two sides of a triangle and the closing side gives me the addition of two vectors. So that guy is vector A plus vector B, and this guy is vector A and this guy is vector B. Makes sense. Now let's talk about another situation. Let's say that there's a football here and there's one player which is hitting the football in this direction, and let's say the modulus of vector A here is nothing but 6 again. Right? So there's a player who is hitting the ball here from 6 Newton force, which is represented by this vector A. Possible. And there's another player which hits the ball here in this direction with 4 Newton force. See, both these are vector quantities, right? That gives me the amount of force, which is 4, or I can just write the modulus of vector B is nothing but 4, right? And this is modulus of vector A, which is 6. It means the force is 6 here and the force is 4 here. And I also know that there are two different directions possible. Where would the football move in this question? Can the football go like that? Not at all. Can football go like this? No, because there are two forces acting on the football at the same point. Can the football go in both the directions? It is possible only if it tears off. Now, if I know that the ball has to move somewhere, it has to move in the sum of these two guys, and that would represent the addition of these two vectors. How will I do that? What I do is just complete this parallelogram like that. And I know that if this is vector B, even this is vector B because it's got the same magnitude and direction. If this is vector A and this is also vector A, same magnitude and direction. So I know that from the triangle law, if this is vector A and that's vector B, this would be the sum of the vector A plus B, and that is vector A and vector B for me. This situation arises if at all there are two forces acting at the same point. And where would the body move? Physical example, just a football and two forces acting on it. So where would the ball move? It moves in this direction. That's it. All right. In this case, there is a displacement of the body by itself. It moves from here to here. But again, it moves from here to here. if I have to talk about the sum of these two displacement in vector form, it means I need only one direction and some magnitude, so it has to be this guy. So these are two laws, guys, and that's why we need different rules in vectors. This is very interesting topic. So we will learn all the new rules of addition, subtraction, multiplication, which is very, very different from the regular addition. So keep this in mind. We're building the basic blocks of vectors. All right.